Hi guys, welcome once to my YouTube channel. Today we'll be solving maximum subarray LeetCode 53. In my last video, we solved LeetCode 125 valid palindrome. I'll be putting the link in the description for those that haven't watched. I'll also be putting the link up in the video. You can click it, go back and watch, like, subscribe to the channel, comment. I want to know what you think. I want to know other ways you can solve this particular problem we are solving, other ways you can get better at solving this algorithm questions, right? So yeah, if you can notice, I'm using a mic from my last video, which I've increased the quality of my audio. It was gifted to me by a close friend of mine. Metete. He's a fellow software engineer. He's a very delightful person to work with. He also has a newsletter, the productivity newsletter. I'll be putting the link in the description box, right, so that you guys can subscribe. So let me thank my guy Metete. So yeah, thank you, and let's get down to the video. So for maximum subarray, as you know, we have been solving what, why, and how for every question. So we're diving into the what. So for what, maximum subarray is a medium LeetCode question. It provides you an array of integers and you have to return an integer, which is a sum of the largest subarray, right? So you'll be given an integer array. An integer array is just an array that will contain only integers. So like this, you have numbers, you won't have characters, you won't have any other thing aside numbers, right? So I'm supposed to find the subarray with the largest sum. This is highlighted in blue. If you just hover over it, you will see a subarray is a contiguous non-empty sequence of elements within an array. I know this might be a little bit too much, so I'll try explaining what a subarray is. So let's assume you have an array, let's say a basic array ranging from 1, 2, 3, 4, 5, 6, and 7. A subarray is a contiguous non-empty. You can see that non-empty is bolded out, so it means one cannot be empty. So if I'm giving examples of subarrays, an empty array will be wrong. So this is wrong, right? It has to be contiguous, right? So that means it has to be arranged in such an order the way it is. So if you have 1, 2, 3, this is a correct subarray, right? If you have 3, 6, 7, this is wrong. So because it's not contiguous, you can see that 3 and 6 were not touching each other in the original array, right? So it means it's wrong. If you have 5, 1, and 4, this is also wrong. So this just means any subarray must be following each other the way it is in the original array. The numbers must be touching the other number the way it was in the original array, right? So you have 1, 2, 3 is the valid example, 2, 3, 4 is the valid example, 3, 4, 5, 6 is the valid example, 4, 5, 6, 7 is the valid example, right? That should be clear. Going on, what if you still don't get this, you can pause it, you can play it back, you can try getting subarrays from yourself to ensure that this is correct. So you can even see from the examples here, from this array you have 4, minus 1, 2, and 1, which is ranging from this to this. So this array, which consists of only one element, the subarray is 1 because it's the largest sum, right? The subarray here is the whole array because it's also a subarray. Okay, so you have plenty subarrays in a given array, I mean, except for this, which is only 1 because you have 1 element. So you have like this, you can have a large number of subarrays that you can get from this. So I'm going to bring out the one which the element gives the largest sum. So this was this, and for this is this. So yeah, that's a clear explanation of everything. For the constraint, you have norms of length, which is the length of the array. It should be ranging from 1 to 10 raised to the power 5. The elements in the array, the individual numbers, will be ranging from negative 10 raised to the power 4 to positive 10 raised to the power 4. There's also a follow-up here. If you have figured out the O of n solution, try coding another solution using a divide and conquer approach, which is more subtle. So guys, if you have done this using divide and conquer approach, I will not be covering this, but if you know how to do it, you can please share in the description enlighten us on how we can do this, and I will definitely reply you so you can see. So that's a clear description of the what. You'll be given an array, you have to find subarrays, and you have to return the sum of the subarray with the largest sum. That's it. So that's a good enough of what. So for the why, so I have this Medium article I've written on this, and obviously I'll put the link also in the description box so you can go back and read in case you don't have enough time to watch the video. So this is what I have explained earlier: valid subarrays and invalid subarrays. We can look into this. So for the why, this algorithm question is a very common algorithm question. Companies like Google, Facebook, and Amazon has frequently asked this in interviews because it tests your ability to recognize patterns and design efficient algorithms. I also have come across this question, like I said here, in an interview. It means most likely if you're a software engineer, you come across this question if you haven't. At its core, the problem introduces to dynamic programming, which specifically it's Kadane's algorithm. I don't know if I'm pronouncing this well, but yeah, I think it's Kadane's algorithm. So this is an introduction of dynamic programming. This is one of the first questions I would introduce to dynamic programming, right? Kadane's algorithm is an optimization of the brute force solution that will take your time complexity from big O of n squared to big O of n. Yeah, so understanding this transition is crucial for improving problem solving skills and writing efficient code. In real-world applications, this is being used in financial industry, in image processing, and also network traffic and load balancing. Right. So in financial analysis, this is used in stock market predictions, right? It helps to determine the best time to buy and sell stocks to maximize profit. You know, since this algorithm is getting a maximum size from a range of things, right? So you can use it if you have a data of stocks that you buy and sell and get profit. You can use it to get the window that you'll be able to get the maximum profits, right? Also in image processing, it plays a role in object detection by identifying the most relevant parts of an image based on pixel intensity, right? So in image processing, let's say you have an image and you have an object in the image, right? So obviously the object's pixel intensity will be higher than others, right? This algorithm will help you determine or pick out the objects. So also in network traffic and load balancing, it helps to determine periods that have highest traffic spikes, that is the time that you have highest request hitting your servers, so you can optimize resource allocation. Mastering this algorithm not only prepares for coding interviews but also gives you a foundation to tracking real world optimization problems, right? So you can use it to do plenty of things. As long as you have data, right, you can use this algorithm to determine a subset of the data that has high or the highest implications or interactions. So you can use this in many other places. So for the how, we'll be solving this using two methods, right? You know, one thing is Kadane's algorithm we use, which uses sliding window technique, and this is an optimization of a brute force, right? So to show you how we get to the Kadane's algorithm, I'll start with brute force. I'll show you how to solve using brute force, and I'll also show you why brute force might fail in this particular algorithm, and we'll get the Kadane's algorithm, which is the optimized solution, right? So let me go back to the question. So for our brute force, so we'll be solving this using a simple method. You know, we are given an array of numbers and I'm supposed to find the subarray with the largest sum. So we'll be finding all the possible subarrays. I'll be keeping track of their sum. We'll also be keeping track of the maximum sum. So anytime we have a sum of a subarray, we'll compare to the maximum sum, and then we'll be replacing the maximum sum. After getting all the subarrays, we'll return the maximum sum, right? So it's as simple as that. So let me write the pseudocode. We'll initialize maximum sum. So we have an outer loop. In the outer loop, we also have an inner loop. So we'll be calculating each subarray's sum, then we'll get the maximum. So we'll get the maximum between the subarray sum and max sum. Or we'll replace the max sum. So replace the max sum with the maximum between the subarray sum and the max sum, and after the loop we return max sum. So it's pretty straightforward, right? So yeah, let us get down to it. So we have int max sum is equals to an integer, that's minimum value, right? Into the outer loop, so we have I less than nums.length. We have I plus plus, so we'll have another loop and j equals to I less than nums.length, I plus plus, right? So okay, so I think here is where we initialize the subarray sum, right? Then with this loop we'll be calculating each subarray sum. So you have your subarray sum equals to plus or minus nums of j, right? Right, so after doing this, what you need to do is we'll change the value of max sum to the, this is math.max, so this is subarray sum and max sum, right? After this, what we do is we'll return max sum. So let's run this. Okay, so something is definitely wrong. Then this is j, let's see, nums.length 0, minimum value, max. Yes, this should be it. time limit exceeded. So something is wrong, guys. Okay, so let me cross check again. J, right, J. Okay, so this is good. So I didn't mix up earlier. So let me submit this. Oops. So you can see we have time limit exceeded, right? And if you check, this is a very large array. So this might be even 10 raised to the power 5. And that is why, because our solution runs in big O of n square. So it means we won't be able to solve this efficiently. So let's view less. So because of this, we will be doing the optimized solution, which is Kadane's algorithm. So this is why you shouldn't use brute force. To solve your simple problems with a small size of array. However, it won't be able to solve this large set of array. So this uses what we call sliding window technique. So maybe in another video, I'll get to explain in detail what sliding window technique does. In this video, I'll just give you a brief description and overview of everything so that you can get on solving the algorithm, right? Sliding window technique is used for problems that require you to find subarrays or subset of arrays to find sum or work efficiently given a particular window, right? So let's take for an instance, we have an array 1, 2, 3, 4, 5, 6, and I require to find the maximum, let's say find the maximum sub of subarray with length 3. Right, so you'll be given this array and you'll be given the length 3, and I require to find the maximum subarray. So that means you'll be picking out 3 of each. So you'll be picking out, if you're using brute force, right, you pick out 1, 2, 3, right? You also pick out 2, 3, 4, right? You pick out 3, 4, 5. You pick out 4, 5, 6, right? So this is what you do if you're using brute force. However, if you're using sliding window technique, what you do is you create a window, right? You have a window. You create a window with 2 pointers, right? So you have left and right pointers. After that, you'll be taking the window of 3 and be sliding it. So for each slide, you'll be performing operations using only left and right pointers. So let me explain why we're doing that. So if you notice this solution, you notice that there are similar things. This 2 and 3 is similar here. 3 and 4 is also similar here, right? 4 and 5 is also similar here. So for each time, we are recalculating things you already have in the previous array. So what you do is, in this window, you have 1, 2, 3. Your left pointer is 1. Your right pointer is let's say 3, right? So when you move to this one, you remove your 1, which is your left pointer, and you take your right pointer to add a new value, which is 4. So let's say in the first round, you have 1, 2, 3, right? So you calculate the sum. Let's say 1 plus 2 plus 3. So in your next iteration round, instead of just picking out the element again, what you do is, using this your sum, right? You use your result from the previous round. You do 1 plus 2 plus 3. Remember, this is already calculated for. What you do is you do minus 1 and you do plus 4. So you remove the first element, which is your left pointer. You add in another element, which is your next element, which will be your right pointer. So it will be like this. Let's do this, right? So it will be similar. So this should be for your 2, 3, 4. Right. For the next round also, you do similar thing to this. Let's say this for the 3, 4, 5. And what we're doing here is we're calculating at each index, right? So we have for the 3, 4, 5, right? So you have this, you have this. So you take this also as your previous sum. And as you did before, you remove this pointer from it, which was your left pointer, and you add in a new pointer, which is your right pointer. So you do minus 2 and plus 5, right? So everything is compounding. For your next round of iteration, also, you do a similar thing. So you have 4, 5, 6. So what you do is you remove your left pointer, which is 3 now, minus 4. Then you add your next pointer, which is plus 6. So this is what it looks like. So instead of recalculating again, so I'm doing 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6. I mean, depending on what you're given to do, right? You'll be doing this. You have a window, you have a sum. All you'll be doing is you'll be sliding it, and for each index, you are going to remove a left pointer and you add a right pointer. So that's why it's called sliding window. You have a window. All you do is you move, you reduce, and you add. So everything is cumulative, right? So yeah, if you don't understand this fully, you can pause and try doing this yourself. Like I always say, put this down in writing, have a paper and pen, do it, add it up, and you see everything will be clear to you. So yeah, so for the Kadane's algorithm, right? So what we are going to do, instead of looping twice, what we do is, so let me do Kadane's. So Kadane algorithm is saying at each index, the maximum subarray at each index is equal to the maximum in between. So the maximum subarray at each index is equal to the maximum, right, between the sum of the maximum subarray at the previous index with the element at that index. So between the sum of the maximum subarray at the previous index with the element at that index and the element at that index. So let me write the formula for this. Let's say I have max subarray at I, right? So it is equals to math.max sub array at I minus 1 plus norms of I comma norms of I. So it's maximum subarray. So yeah, this one is the maximum subarray at any index is equals to the max of this and this. So having two things, right? So this is just giving this. So what it means is if you have an array, so let's take this, right? So I think first things what we are doing is we are initializing. We'll initialize the max subarray at the first index. Since there's no previous index, the max subarray at 0, which is the first one, it will be minus 2. So we're initializing to the first element of the array, right? So at the next one, it will be the sum of, okay, it's a maximum of minus 2 plus 1 and minus 2, which gives us minus 1. So in the next one, at index 2, which is at this index, we'll take this, which will be minus 1 plus minus 3, right? Or minus 3, right? This makes sense. So you have minus 1 plus minus 3 or minus 3. So what we get is, this is minus 4 minus 3. You have minus 3. So this is the maximum sub at this index. So you go to the next index at index 3, which is at this 4. So you have minus 3 plus 4, right? Or 4. This will give you minus 1. This will give you 4. So this is 4, right? So at the next index, you have maximum subarray at index 4, which is minus 1. You have 4 plus negative 1 and negative 1. So the answer here is minus 3, right? So at the next index, which is this, so at subarray 5, you have a minus 3 and 2 or 2. Oh, sorry, this is 4 minus 1, this is 3. So this will be 3 plus 2 and 2. This is 5. So at the next index, which is index 6, right? So we already have 5, which is our previous max sub. So it will be 5 plus 1 and 1, right? This is 6. For the next index, so you have 5, you have minus 5, and you have minus 5 here. This is 0 and minus 5, so this is minus 5, right? So we also have the last one, so which is maximum subarray at this index. So this will be minus 5 and 4. Okay, this is actually 0. This is 0. Sorry, guys. So this is 0 and 4. And this will give you 4. Right. So this is what you get. So from all this, you see that the maximum sum is 6. So this will be your maximum sum. So you can see they got 6 here. So you can use this to solve this. If you don't fully understand this, just pause this, go back and watch it again. Or better still, solve it yourself and understand everything that's going on. So this is a clear solution of how Kadane's algorithm works. Let me just write a pseudocode here. So what you do is you first initialize your max sum, then you look through the array, you find the subarray sum at each index, right? And this will be equals to, so before you do this, remember you are initializing your subarray sum at 0, and let's say subarray sum at 0 to be equals to norms of 0, right? So this will be of I. So you find your subarray sum at 0. So this will be equals to the max, which is maximum of subarray sum I minus 1 plus norms of I and norms of I, right? After I find this, so you can update your max sum with the maximum between your new subarray sum and your max sum. After everything, you return max sum, right? So yeah, so let's go down to this solution. Let me comment this out. So let me just get the method definition. Okay, So like I said, we initialize maxsum as nums of I, right? We also initialize subarray sum. So we have a for loop. So we'll be looping from the second element down till, that's because we already have the first subarray sum. So we'll be looping from number 1. So I is less than nums.length, and we increment. I can just copy this here. So we'll have this. So we'll have subarray sum of I to be equals to max and this and this, right? So after this, you find your maxsum to also be max of subarray sum and maxsum. Right after this, all you are doing is returning maxsum. Let us see if there is no bug here. Okay, this is 0, this is 0, right? This is 1, down to this. Okay, I think we're good. Okay, something is wrong. The array required but not found. Okay, so I've been using this, so I don't need to initialize this. Okay, so another issue. Okay, so this is just subarray. I might be using this wrong. Okay, this is because I was explaining. So subarray sum is a number, it's an integer, it's an integer, not an array. This alone is an array, this is an array. Okay, so I've done well. So let's submit and see. Okay, so you can see this actually submitted and it beats 99.49%, which is a very good number. It's running 1 millisecond. So this rounds it up. You can see there are more challenges: maximum product subarray, degree of an array, longest stop loss subarray. I think these are challenges that we'll look into in the future, and this might also need you to use Kadane's algorithm because it has to do with subarray, right? So yeah, so try doing this in your programming language. There'll be a GitHub link that will have the solution of this particular question in Java, JavaScript, and Python, so you can actually relate it to your own programming languages. If there isn't another one, this pseudocode I've written here is already covering everything you need to know, so you can use this to generate your own solution in your own programming language. I will also put in the GitHub link in the description box below. Thank you. Please like, subscribe, share the video. See you next time.